So we are here at South Pole Station in the Science Lab with Andy Stillinger, and Andy is an electrical engineer with the EGOS project. And Andy, first of all, can you tell us just a bit about what you do here and a little bit about the new power system that you actually designed for this year?
Okay. Thank you for talking to me. I am, as you say, an electrical engineer. I have been working on trying to improve the reliability of the automatic geophysical observatories, which it's a network that consists of 5 stations several hundred miles out from this location, South Pole, and we've been improving the reliability of the system gradually over the years, so I'm continuing that trend, I hope. We've found some weak links in the current power system, so we've redesigned many of the major components and consolidated just to try to streamline things as well as improve the reliability. So these are the major components that we're swapping in this year. This piece that I have my hand on is what we're calling the power panel. It is really a kind of a glorified junction box for the wind turbine. We have a 1.5 kilowatt wind turbine and about 500 watts of solar panel. So these need to come together nicely and work with a battery charger so that the 4 large batteries that we have will stay as charged as we can keep them during the harsh winter conditions. It gets down to minus 100 degrees Fahrenheit in the winter, and the solar panels keep the batteries charged in the summer. So anyway, that's what this panel does. It allows connection of the wind turbine and solar panels down at the bottom, and we have what are called current shunts here for measuring the various currents and voltages in the power panel. Over here, this big unit acts as a heater, and it also regulates the voltage coming out of the wind turbine. In a strong wind, we will have about 1.5 kilowatts of power available, but we don't need to use it all for science equipment. So we have to somehow load the wind turbine in a high wind so that it doesn't overspeed and damage itself. So this device here burns off the excess power that we don't need. In the winter, as I mentioned, it gets very cold, so we make use of some of that excess wind power. And this unit here, although it's not completed, it's just a 2-foot long by 10-inch wide heatsink, one of 2 that will be placed inside our shelters that contain the electronic instruments. So this will help to keep the instruments warm. They unfortunately will not run reliably below minus 40 degrees. So we use these heaters to raise the temperature of the shelter from whatever the outside temperature is, as I say, down near minus 100 all the way up to minus 40. So that's what these 3 major components are doing. Okay,
so can you tell us a bit about how you got involved with the project and how you got to Antarctica? I mean,
well, that's for me an interesting question. I think you have talked with my coworker Bob Melville. He came to a point in his life where he needed to make a career change, and he knew somebody who was working down here, I guess. So he came down on his own, and when he came back, he started to twist my arm, saying that I was just the perfect person to have down here working on this kind of equipment. So after a couple of years, I finally gave in and decided to come down here. But I will say, backing up a little further in time, I had met Bob through one of my other major activities throughout my life, amateur radio, and that has allowed me to learn about many of the things that are used and worked on down here. Radio equipment, antennas, power systems, batteries, you name it. So that's kind of how I got involved with all of this.
Okay, and so you've been coming to Antarctica now for a number of years.
Yeah, 4 years.
So
This
tell
is
me
my
about
4th year.
what's the most amazing thing about being here?
Oh boy, that's really tough to say. There are a lot of things that are, I would say, tied for being amazing. Not the least of which are the people. Very interesting, very knowledgeable people doing all sorts of things that I just never would have expected back home. Of course, the terrain and the views outside. I find it interesting that I get so used to the very high altitude here. We're at 9,300 feet above sea level, but with the cold air, the pressure altitude, or the effective altitude, is over 10,000 feet, and some of our remote locations are effectively even higher than that. So when I first came down here, it was a bit hard to breathe, and it felt quite cold outside. But after several weeks of working here, you strangely do get used to it. So those are a couple of the interesting things.
Okay, Andy, thank you so much for your time and for your great explanation.
Okay, well, thank you very much, and I appreciate you talking with me.